What's up, all? I'm really excited. I'm happy to be here to hold this new topic about the post-tension concrete beam, how we can design and model it in Autodesk structural bridge design. So before to start with the design, the modelization, the design, and the analysis, the thing you must know is why we're talking about what is the post-tensioning. Post-stationing is a form of prestressing, and prestressing simply means that the steel is stressed or pulled or tensioned before the concrete has to tension the concrete has to support the surface load. So post-tensioned concrete means that the concrete is poured and then the tension is applied but is still stressed before the loads are applied, so it is still prestressing. So is what we are talking and is what I'll show you during this presentation. So before we start, we might just open a new window. We open Autodesk structural bridge design at the environment, the software, and you can see this is the more recent project. So I will create here. You can see here we have the bridge standards, and you can see here we have the pre-tension press test, and we have the post-tension concrete. You select for this single design beam, you select the post-tension concrete, and we can go here for the single design, and we select the post we select this, and I'll click OK and open. After the next step is to create the concrete materials parameter and the reinforcement too, because we mark some reinforcement and add the prestressed strength. Here we can change the characteristic strength. We add this, and for the initial prestressed force, it will be in 70%, 75%. After we start the modeling, I can go here, not for no not that for I can go not for this menu, but I can select just only design beam and select the section. After selecting the section, I must click for this plus button, and here I select a concrete beam. After selecting concrete beam, it allows me to define prestressed concrete beam components. After the concrete range, I will change to put I beam. After I change the range and I put a I6 beam, and after I must change the must change the decrement hook. It must stay here, there, and after I put for the coordinate x0, and it puts me on center. I create the second composite. I create the second beam. It will be a parametric shape, and I put 2000, and here I put 200. After, to create the rectangle a slab, it will be our slab, and I'll put the same to change the increment hook, and to make for the x0 and for the y, I put 1 and 10 2. And after I finish to make the modeling, I model it, the first step of modeling. After, this next step is to create the tendon. For the creation of tendon, before I just select the define post-tension tendon, and I click here. To click there, the first of all, before you start to click or to create your tendon, to create your tendons inside the precast beam, you should define those parameters. Especially for the number of strands, I put 18, and after the duct diameter, the duct diameter will stay the same, and for the strand offset, I put 15. After I click, and after to click, you can see I already defined some things, but I can restart, and I put 15, and I click here. After I click, I already create, but I need to change some things. So these things I should change it before, but here there is another a way. I can just put 70, 700, and here 700. So this is our prestressing. After to do it, I'll just define the first profile. My first profile, I select. You can see here, I select this option, and after I select the profile. For the profile, I will select the profile coordinates are must relative to reference, and I uncheck the fix and put minus 0.5. And after, you can see when I put transparency, you can see this is our prestation beam created directly. And I can go back, and again, it's very important that it's our first thing, our first. After to do that, I can go to prestressing. For the prestressing here, as you can see, there's some for this option. We just change the one thing is just nothing you can change for the stressing tendon data because you are already defined it. So for the loss of prestressing, the loss of prestress here, the loss of prestress, we can put 3 millimeter, and it's the only things we can change here about the jack friction. The value must be 10 kilonewton by kilonewton, and after I click there, and you can see here that is a first modeling. Here is the parabolic. So, but to reinforce and to make it strong and to eliminate the state service and deflection of the beam with 10 meters, we must add two other prestressing steels. But before to do that, we need, before to do that, we need to go there. Excuse me. So to create those two other prestressing steel, before we just go to the material and add another prestressing strand, and here we can change the initial prestress. You put it for 79, and I go back to the design beam, and when I'm go back to design beam, I go to beam definition tendon, and when I come in there, I just create a new. For this new, the first of all is to define the number of strand must be 1, and for the duct diameter must be 0, and for the strand offset must be 0. After I select those two, and I have the ability here to change. The first overall here, first ability here, I just put minus 2. And here, the offset for Y, and here 160. That's okay for me. I already changed, and I can click good. So here, there is nothing special to change here, because after to do that, what I can do next is to go there and define profile. For defining profile, we can just go to the prestressing. It is staying the same, but we can change the loss of prestress. There is no encourage a slip. I must put 0, not for all. Here 0, 0, and 0. I do the same for this tendon, because that is okay. This tendon is 0. This tendon, I put the same 0, not for all. 0, 0, and 0 here. And after to do that, I'll back to the first tendon and change the load jack friction. This is the jack friction. If you don't know, this is the jack friction. Is this a load, this strength, this force apply here on our steel stress. And after, what we can do next is I already change, not for all. I put here 3 millimeter. This be good. I can go there. Everything is okay for me, and I can click, because we can verify. You verify some things is there, is good. And after to do that, After to do that, I can click here. And after to do that, the second things to do is to add some reinforcements. For reinforcement, we just put here, we change the reinforcement, we change the spacing, exact spacing, reinforcement by face, first face, we can put the cover for 30, and the second cover 30, it be okay, and I finish. And after to do the next, I already finished my modelization. I can go there and you can see what it looks like. You can see here we have two tendon and one tendon parabolic. After to add load, the first load here is superimposing load. This superimposing load will just add it generates. It must be this superimposing load. Just go back here. We had the first load for not for 2 but 6, and we just put here 6, and this 6 load is applied here. We can add another component. We put 2 and 2. After we generate, after to generate our load, the second must be either it be this and that load here. We can select it. It be a live load, and I'll go back here. I put the name, and I can generate here. I put 12.4. 12.4. This is one, and the second here I can just put I can put 5 and 5, but I can define the position to 7, and I click OK. So the last, it must be this load, not that with the here associated, and it will be here. The first might be 10 and 10 here. So we add the components must be just we add this 200 kilometer in mid span. 200. I select 200, 200, and 200 here. So I can put in span, I put 60, and here I put 70. This is our stand. And after I can click OK. We can see this is after you launch. You can launch to verify the results. So for verifying the result, I can go just quickly. You can see here service load. You have it. You can have the result. You have the beams quantities. You can go for the live. You see here in service and ultimate. You can see. And for the share, you can see this the value. You can see the result, the note calculation, and some warning. We can have it. And you can see the variation of the result at point of interest. You can go, you can change everything, shrink and creep. You can go for difference temperature. Here you can create, calculate the shrinkage and the creep, the positive difference of temperature. You can see the result. You can do the same for the stress. It indicates the same, and so that was just the small introduction, the small things which I will just want to share with you about the post-tensioning concrete beam. If you like it, thank you, and don't hesitate to share your thought about and make some other maybe a remark and other things. Thank you so much. See you later for another presentation. Thank you. Bye bye.